Hi students, problem number 13 in MCQ. Photons of wavelength lambda are incident on a metal. The most energetic electrons ejected from the metal are bent into circular arc of radius r by a perpendicular magnetic field having magnitude B. The work function of the metal is to be determined. So this question has been asked in KVPY exam as well as has been asked in the other competitive exams also. So this is somewhat a new type of problem. Okay, so far we have not solved this type of problem, but it is also quite interesting and easy only. Now you can see here, this is a metal whose work function is phi naught. So a wavelength lambda is incident. So the corresponding energy is hc by lambda. The photoelectrons emitted when they are coming out, a perpendicular, a transverse magnetic field is established, okay, in the y-axis. So that the electrons, when they travel perpendicular to the magnetic field, they will be moving in a circular path. Is it not? The ejected photoelectrons now, they are moving perpendicular to the magnetic field, so that their path will be circular due to magnetic Lorentz force. So in the circular path, the electrons experience two forces. One force is the centripetal force in the circular path, and it is equal to the magnetic Lorentz force. So that I am going to express first. If m, see, E is the charge of the electron and m is the mass of the electron, and v is the velocity of the electron in the circular path. So first I will take centripetal force is equal to the Lorentz force, magnetic Lorentz force. So centripetal force, this is m into v square divided by radius of the circle is given as capital R, and that is equal to Lorentz force. So Lorentz force is B E V into sine 90. Sine 90 is 1. So that now this power of this velocity can be cancelled with the V here. So mv by r is equal to Be. Our velocity V is equal to B E R divided by m. So this is the required equation number 1. So the velocity of the electron is V equal to B E R divided by m, or E B R divided by m. In any form we can write. Now after this we have to go for the regular equation, namely the Einstein's photoelectric equation. Okay. So the incident energy H C by lambda. This is utilized in two ways. Now the work function is phi naught plus half m v square maximum. So this is the maximum kinetic energy. So that I am going to substitute this value for V in the Einstein's photoelectric equation. So left hand side is what? Hc by lambda. So Hc by lambda, this is equal to phi naught plus half mv square can be written as m divided by 2. So everywhere they have given m suffix e, that is the mass of the electron. Okay, that final answer we will substitute. Everywhere if you write means it will be congested, is it not? So m is the mass of the electron, which is nothing but me only. Okay, only the final result I am going to substitute. So this half m becomes m by 2 into v square. In place of v square I am going to substitute e b r by m the whole square. So that this is e b r by m, okay, e b r by m the whole square. Okay. So h c by lambda is equal to phi naught plus this m can be cancelled with this m square. So this is what E square B square R square into this m, okay, into this m divided by 2m square. So this is what 2m square. Okay. Once again I am adjusting here. In the denominator and the numerator I will multiply by 2 once again. So that h c by lambda is equal to phi naught plus I am going to multiply here by 2 and here also by 2. So that this will become 2m the whole square. So what will be this now equal to 2 into m, I will write 2m, okay, and this will be E B R by 2m the whole square. Okay, I multiplied by 2 so that it has become 2m. So that here also if I will multiply, this will become 2 square m square. So 2m the whole square. Understand? We need an expression for what? Only the work function. Is it not that? Therefore, okay, therefore the work function phi naught is equal to, the left side is what? hc by lambda. Okay, all these terms should be brought to the left as minus. So minus of 2m into EBR by 2m the whole square. So this is EBR by 2m the whole square. So this must be the final answer, is it not? So we will verify here which option is the correct option. See here, B and C looks alike, but here there is a plus sign. This need not be the answer, is it not? So this must be the answer. So hc by lambda minus 2m. Okay, now in the final step I will write m. E is the mass of the electron, and in the bracket also 2me I can write. Understand that? So which is the correct answer is option D. Okay, therefore option D is the correct answer. So the steps are little bit lengthy, that's all. Okay, so systematically if you do means you can successfully get the answer. So here the clue is hidden here. Actually when the electrons are ejected from the metal, it is traveling perpendicular to the magnetic field. Separately I have drawn the picture. Okay, so when the electron is traveling perpendicular to the magnetic field, it experiences magnetic Lorentz force that is to be equated with the centripetal force. So from that the expression for velocity of the photoelectron we will get. Then in the Einstein's photoelectric equation, if you substitute systematically means we will be getting the correct answer. I hope you must have understood well. Fine.